I welcome all the students. We have started learning the unit number 4 and we have covered the point to Cohen-Sutherland line clipping algorithm. Okay. In the last session, we have learned Cohen-Sutherland line clipping algorithm in detail. So today's session, we are going to learn and concentrate on the one more algorithm which is used for the line clipping. Okay. And the name of algorithm is Liang and Barsky. Okay, so these are the two scientists, Liang and Barsky line clipping algorithm. Okay, and then we will continue with the polygon clipping algorithm. Okay, so today's point of discussion or today's discussion is related to Liang and Barsky line clipping algorithm. So again, as we are having the Cohen and Sutherland line clipping algorithm, where the name of Cohen and Sutherland, these are the name of the scientists who have designed or developed this algorithm. Similarly, the Liang and the Barsky, okay, these are the two scientists, okay, who has came with the new algorithm, okay, for the line clipping, and it is more faster, okay, as compared to our previous Cohen Sutherland line clipping algorithm. Okay, let us start learning with the Liang Barsky line clipping algorithm. Okay, now why we go for the different algorithms? Okay, the reason behind is we want to perform the line clipping faster. Okay, so the faster line clippers have been developed that are based on the analysis of parametric equation, okay, of a line segment. So here we, instead of the way we have used in the Cohen Sutherland line clipping algorithm, okay, so we want to have the line clipping should be faster. So the analysis of the, okay, or we have developed the different line clipping algorithm which uses the parametric equation of the line segment, which can write in the form, okay. So how these parametric equations are written? Okay, so these parametric equations are written as what is the, how to find out the x value. Okay, so x is equal to x1 plus u into delta x. The value of y is equal to y1 plus u into delta y. Okay, and the value of this u, okay, is going to vary between the 0 to 1. Okay, so value of u varies from 0 to 1. Okay, so these are the parametric equation that we can use in the algorithm. Now, as we are already knowing what is the meaning of delta x, okay, so the delta x indicate that the difference between the x2 minus x1, and the delta y indicate the difference between y2 minus y1. So that is what we are considering the displacement of the x value and displacement in the y direction. Okay, so the line is having the starting point and end point. So the starting point of the line, okay, is called having the value x1 y1, and the end of point of the line is having the value y2 x2 minus x2 y2. Okay, so x1 y1 and x2 y2. So we are using this delta x as x2 minus x1 and delta y is y2 minus y1, which indicate the difference between the displacement in x and y direction. Okay, now whatever equation just now we have seen, okay, whatever the parametric equation just now we have seen, these parametric equations are used by the scientists, two more scientists, Cyrus and Bake. Okay, so this equation, whatever this part, whatever these equations are there, so these equations are used by the Cyrus and Beck, who have developed an algorithm that is generally more efficient than the Cohen-Sutherland line clipping algorithm. Okay, so before we have started using, before the development of the line clipping algorithm by Liang and Barsky, okay, the two more scientists, Cyrus and Bake, they have developed the line clipping algorithm. Obviously, it is more efficient than the Cohen-Sutherland algorithm. Okay, and they have used this parametric equation. These parametric equations are used by them. Okay, but further, okay, or later, after some time or further, okay, the Liang and Barsky, they have independently devised an even faster parametric line clipping algorithm. Okay, so the line clipping algorithm of the Liang and Barsky is even faster than the algorithm of Cyrus and Bake. Okay, so and this algorithm, which is faster than this, even more faster than this, is known as, and it is become famous, and it has, everyone has started using it, and everyone has referred the algorithm as Liang and Barsky line clipping algorithm. Okay, that was one of the reason. Okay, we are going to learn this algorithm, okay, in today's session. The main reason of learning this algorithm, or the advantage, that this algorithm is faster or more efficient as compared to the Cohen-Sutherland algorithm, as well as compared to the algorithm designed by Cyrus and Bake. Okay, let us start understanding the how this algorithm, what is the procedure of this algorithm. See, though we move to different algorithms, okay, the general steps are same. Okay, I think we have learned in Cohen-Sutherland algorithm, the general steps are maybe we find the endpoint code, or we find the visibility of the line, and then we have to find out the intersection point and so on. Okay, so only the equation or the method that we are having will be changes, and the reason for it to have a faster line clipping algorithm. Okay, so let us move to the next slide to understand the things in the detail. Okay. In this algorithm, okay, so in this algorithm, we first write the point clipping condition. I think under the point clipping, description of the point clipping, we have seen some of the conditions which are there. Okay, but now we are going to write this condition in a parametric form. Okay, so the Liang and Barsky uses the, definitely there uses the parametric equation. Okay, and so we are defining the first how point clipping condition can be written in the parametric form. Okay, so how it is written in parametric form, that we are considering, that see, I'm not considering my x value only, but I'm considering it is equal to, just now we have seen, x1 plus u delta x. Okay, so now I'm considering that in parametric equation, I considering this value as x1 plus u delta x. Okay, it should be, or it, the value of this should lie between xw minimum and xw maximum. Okay, as all of us knowing that the xw minimum always represent the left edge of the clipping window, and xw maximum, it always refers to the right edge of the window. Okay, so the x1 plus u delta x value should be greater than xw minimum, okay, or greater than or equal to xw minimum, or it should be less than or equal to xw maximum. So it should lie between this. Okay, and instead of considering this value, I think in normal way we have considered it as only x value, but here we are considering the value to be x1 plus u delta x. Similarly, okay, we are considering for the y. Okay, so for similarly for the y coordinate, we are also considering that the y1 plus u minus delta y. Okay, definitely delta y will consider y2 minus y1. The value of delta y is y2 minus y1. Delta x is x2 minus x1. Okay, so y1 plus u delta y must fall, the range or the value of this must be in between yw minimum and yw maximum. Okay, what is yw minimum? The yw minimum indicate the bottom edge of the clipping window, and the yw maximum indicate the top edge of the clipping window. Okay, so this value y1 plus u delta y should be greater than or equal to yw minimum. Okay, and it should be less than the yw maximum or the top edge. Okay, so these are the two parametric forms or the equation, okay, we are using to identify or to find out the point to be inside and outside. Okay, for point clipping we are just considering this. Okay, now if we are considering, see, I'm having the four condition over here. Okay, so each of these four inequalities, what was my four condition? This value, okay, what was my first condition? This value should be greater than or equal to xw minimum. Second condition, this value should be less than or equal to xw maximum. Third inequality or third condition is the value, this particular value y1 plus u delta y should be greater than or equal to yw minimum, and y1 plus uwy value should be less than or equal to yw maximum. This is my fourth condition. So these are my 1, 2, 3, 4 inequalities. So each of these inequalities can be expressed as, okay, so how we are expressing it as u into pk. Okay, so p is I consider as a point. Okay, so I'm considering the line has the point P and Q, so I consider it as the UPK less than or equal to QPK. And what is this K indicate now? Here the K indicate the value 1, 2, 3, 4. Okay, so this K is equal to 1, 2, 3, 4 indicate that these are my four conditions. Okay, so in this case, okay, though it is not mentioned here, I say that one should indicate the left, the two should indicate it as a right. Okay, so this is 1 K value, this is 2K value, so this is 3K value as the bottom and the 4K value as a top. Okay, so K is equal to 1, 2, 3, 4. Okay, so these are the parametric equation that we are using, or those are used in the Liang Barsky line clipping algorithm. Okay, now here how I can find out the parameters of P and Q here. Okay, so as we are using U into pk should be less than or equal to qk, so where the parameters of p and q are defined as, okay, you just can find how these parameters are defined. The first one, p1 is equal to minus delta x, and the q1 is equal to x1 minus xw minimum. Okay, so when I'm having the p1 value is equal to minus delta x, I consider the q1 value should be x1 minus xw minimum. Okay, so if my p2 value is delta x only, not minus delta x, my x2 p2 value is delta x. See here, what is the meaning of minus delta x? See here, the meaning of what is delta x here? The delta x value indicate the x2 minus x1. Okay, so that is the difference that we are having. So it indicate that x2 minus x1 value. Okay, it indicate x2 minus x1. And now when I will get this value to be minus, when I will get minus delta x value, see, suppose I am having the x2 value is 200, x1 value is 100. So I will get 200 minus 100, my value is will be positive. When it will be minus delta x, it indicates that my x2 value is less and x1 value is greater. Since I am having x2 is 100, x1 is 200, so I will get this value as minus delta x. Okay, so when p1 is equal to minus delta x, the q1 should be x1 minus xw minimum. The p2 is equal to delta x. Okay, p2 is equal to delta x indicate that positive delta x indicate that my value of x1 is less and value of x2 is greater. Okay, so then I will get x2 minus x1 is equal to positive delta x. Okay, then at that time the qt is calculated. Qt is equal to xw minimum minus x1. You can find here what is the difference is, if this is minus, this will be x1 minus xw minimum. It is positive, this will be xw minimum minus x1. Okay, so similarly when the p3 is equal to minus delta y, so now I'm considering for delta y, then the q3 is equal to y1 minus yw minimum, and p4 is equal to delta y, then my q4 value is represented as the yw maximum minus y1. Okay, so here again the same thing as we have explained for the x2 minus x1, minus delta y, when I will get the delta y value is minus, if my value of y2 is less and y1 is greater. Getting me? Suppose my y2 value is 100 but the y1 value is 200. So what I will get? The value will be minus or negative value. Okay, so similarly, so we are using all these inequalities can be expressed with the help of the parameter p and q, okay, which is defined over here. So this is, I consider it as the basic equation or the basic which is used by the Liang and Barsky line clipping algorithm. Okay, let us continue our discussion. So I'm just moving to the next slide to understand some of the algorithm procedure in detail, and at the last 2-3 slides we will consider the actual algorithm or step-by-step algorithm or the procedure. Okay, let us continue our discussion, okay, to understand it. Here I repeat again that the procedure is same. Okay, what is the difference is the way we are finding the intersection point, the way we are finding the visibility test will be different. Okay, so which depends upon the parametric equation. Okay, so I'm just coming to the next slide now. See here, now further discussion of this Liang Barsky line clipping algorithm. What the point we are mentioned here is any of the line that is parallel to one of the clipping boundaries is any of the line which is parallel to the clipping boundaries. What it means? What it means? Suppose this is my rectangle. Getting me? So this is my window. Okay, this indicate my window. Okay, consider this is my window edge. And now suppose I just change the color here, and suppose this is my line. Okay, what this line indicate? This line indicate that, okay, this line indicate that it is parallel to, okay, so any one of the line that is parallel to one of the clipping boundaries. So obviously this may be parallel with the, suppose I consider this is my bottom edge or the top edge. Suppose I'm having this line will be parallel to my left or right edge. Okay, for the value k, okay, corresponding to the boundary, what is the k is equal to? K may have 1, 2, 3 and 4 corresponds to, see here we are using pk is equal to 0. Okay, so pk is equal to 0 for the value k, and k indicate 1, 2, 3, 1, 2, 3 and 4, where this 1 indicate left, 2 indicate right, 3 indicate k value, 3 indicate bottom, and k value 4 indicate top boundaries respectively. Okay, so now first we are considering whether the line is parallel to one of the clipping boundaries or not. Okay, now next is if for the value k we also find qk is less than 0. See, we have having the value p and q. In previous slide we have seen when the pk, what is the value of p and what is the value of k. If p value is delta x, what is the k value? If the p value is delta y, what should be the q value? Okay, so similarly we are considering if for that value of k we also find qk is less than 0. Okay, if qk is less than 0 and the line is parallel, see this is my parallel line, and for this line the qk value is less than 0. Okay, then the line is completely outside the window and can be eliminated from the further consideration. Okay, I think this is what the example of this is my line which is parallel, this is my line which is parallel, this is my line which is parallel. Okay, and these values, these lines are also having qk value is less than 0, then we can say the line is completely outside the window and can be eliminated from the further consideration. Okay, so just moving to the next point, if the qk value is greater than or equal to 0, okay, if qk is greater than or equal to 0, the line is inside the parallel clipping boundary. The line is inside the parallel clipping boundary. Okay, now here, after considering these points, okay, that we have just now, okay, considered in the slide, okay, I just continue the discussion over here. Okay, I'm just going to continue the discussion here. Is when pk is less than 0, okay, when the pk is less than 0, the line proceeds from outside to inside. Okay, so here we are considering that whether my line is moving, my line is proceeds from the outside to inside, or whether it is inside to outside. Okay, so further this algorithm checks this condition using when the pk value is less than 0, the line proceeds from outside to inside. Okay, now if the pk is greater than 0, okay, if p, see here what is meaning of k. Here the k indicate that it may be the k may have the value 1, 2, 3 and 4. So if it is 1, indicate p1 indicate that it is for the left edge, p2 indicate that it is for the right edge, p3 indicate it is for the bottom edge, and p4 indicate that it is for the top edge. So we are considering for all the 4 edges. Okay, so this pk indicate that I have to consider this for all the edges. Okay, now if pk is greater than 0, then what it indicates, the line proceeds from inside to outside. Okay, so if this value of pk is greater than 0, my line will proceed from inside to outside. Okay, so these are the conditions that we are considering. Okay, now for a non-zero value of pk, okay, non-zero value of pk, we can calculate the value of u that corresponds to the point where the line intersects the extension of the boundary k as. So here we are trying to find out the intersection point, okay, for the non-zero values of the pk. Okay, for non-zero values of the pk, we are going to calculate the intersection point. So we can calculate by u is equal to qk divided by pk. Okay, so we are just going for the simple formula here is, okay, to clear with, to find out the line intersection, okay, with the boundary k. Okay, suppose my line intersect with the boundary k, and where the k is equal to 1, means the line intersect with the left edge. Okay, 1 indicate left edge, 2 indicate, okay, I just write it here, 1 indicate it is my left edge, the k value, okay, k value 1 indicate it is left edge, 2 indicate it is my right edge, the k value 3 indicate it is my bottom edge, okay, and the k value 4 indicate it is my top edge. Okay, now here that we are going to find out with the help of the u value, okay, that we are going to consider. Okay, now for each line, okay, so this is what we are having for each line, means qk1 divided by p1 means for left edge that we are considering, then the right, bottom and top, each line we calculate the value of parameters u1 and u2. So then we are going to find out the parameters u1 and u2 that define that the part of the line lies within the clipping window. Okay, because we have seen that previously we have checked that the line is not totally outside, so that we can reject. So what indicate it may be partial, but here instead of calling it as a partial, what we are considering, we define that the part of the line lies within the clipping window, means obviously it is partial. Okay, some part of the line is inside my clipping window. Okay, so that is what we are considering. Now the value of u1 is determined by looking at the rectangle edges for which the line proceeds from the outside to inside. Okay, so we are considering that for value u1 is determined by looking at the rectangle edges, okay, for which the line proceeds from outside to inside. So value of p is less than 0. I think we have just seen here. The pk, now the k indicate it is my 1 or 2. So I just consider k, then p is less than 0. P is less than 0. The line proceeds from outside to inside. Okay. And for these edges, we have to calculate the rk is equal to qk divided by pk. So means my value of u, okay, here it will be considered as the rk value. Okay, so edges that we calculate, okay, determined with the help of this. So using this formula further, we are going to find out the, see here whatever the part we have discussed, it is related to if the some part of the line is inside or the line is partial how to calculate, how to find out the intersection point. Okay, so I think in Cohen-Sutherland line clipping algorithm, the procedure to find out the intersection point is little bit time consuming. Okay, it is required more calculation. Okay, so here the Liang and Barsky, okay, Liang and Barsky will try to use the parametric equation, different formulas which will be very fast as compared to the Cohen-Sutherland line clipping algorithm. Okay, now whatever we have discussed, okay, the equation, what it is uses, what is parametric equation and all, okay, that we have used. But now I'm just going to give you the procedure, okay, or we can say algorithm, okay, or the sequence or the steps of the Liang Barsky line clipping algorithm. Okay, so on the next slide we just continue whatever we have discussed. I just combine it into the step number 1 2 3 4. Okay, so let us understand these steps or the procedure. Yes, we can find this is my procedure of the Liang Barsky line clipping algorithm. What is my step number 1? So the step number 1 is line intersection parameters are initialized to value line intersection parameters. Getting, so our aim is to focus on these parameters. Okay, line intersection parameters are initialized to value u1 is equal to 0 and u2 is equal to 1. So should be in the range 0 to 1. So initial value of u1 is 0 and u2 is 1. Okay, then what is my step number 2? See, this is my step number 2 for each clipping boundary. Okay, for each clipping boundary indicate that I have to consider for k value, and k is equal to 1 2 3 and 4. Okay, for each clipping boundary that I need to consider. What is my step A inside this is my actually step number 2. Under this step indicate that I have to follow whatever the next steps are there. For each clipping boundary I have to follow it. Okay, so what is my A? The appropriate values of P and Q are calculated. Calculate the appropriate value of P and Q and use by the function clip test. Okay, so I am using one function which is called as the clip test to determine. So this clip test is nothing but which is similar to the what we can say visibility test we have seen in the Cohen-Sutherland line clipping algorithm. Okay, so determine what it determine whether the line can be rejected or whether the intersection parameters are to be adjusted. Okay, so this is that's why I told it is more similar to our visibility test. Okay, so which will determine whether the line can be rejected directly, so whether there is no need to clip the line. Okay, so that is what we are considering here. Okay, in the step number A. Okay, step number B. Okay, just now we have seen when the p is less than 0. Okay, the parameter r is used to update the u1, and when the p is greater than 0, the parameter r is used to update the u2. Okay, so we are updating the value of u1 or recalculate the value of u1 and u2, update the value of u1 and u2 because its initial values are mentioned as 0 and 1. Okay, depends upon whether the p is less than 0 or not. If it is p is less than 0, parameter r is used to update u1, and when the p is greater than 0, parameter r is used to update u2. Okay, now if updating u1 or u2 results in, okay, u1 is greater than u2, if the value of u1 is greater than u2, then it indicate that we reject that particular line. Okay, so this is the test that we are performing to find out whether the line is totally invisible. If it is totally invisible, it is totally outside the window, okay, clipping window, then we are going to reject that particular line. Otherwise, okay, so otherwise what we have to do, we update the appropriate u parameter. Now otherwise indicate that the line is not rejected. Okay, line is not totally invisible. So we update the appropriate u parameter only if the new value result in a shortening of the line. Okay, so that is what we are going to consider. So we have considered here in otherwise case my line is partial. Okay, I just move to the next procedure or next step now. I just move to the next slide to understand that procedure or complete the procedure and complete the discussion further. Okay, you can just find it here. Okay, the procedure, I think some parts of the procedure is remaining, so I'm just continuing with the procedure. We come to the advantage at the end. Okay, end of the session we consider which are the advantages of Liang Barsky line clipping algorithm. So continue with the procedure that we have started learning. For each, again the same thing is there for each clipping window. So my procedure is continued from previous slide to this slide. Okay, so we have learned in previous slide the step number A, B and C. Now we just consider step number D. See, when P is equal to 0 and Q is less than 0, okay, we can discard the line since it is parallel to and outside of this boundary. Okay, so we have seen this test as the parallel line which is outside the boundary and the parallel line which may be inside. Okay, when the P is equal to 0. See, when the P is equal to positive, okay, it is not 0, it is having some positive number, not 0, indicate that the line is, some part of the line is inside the clipping window. So we have to consider the intersection point and the further. Okay, so the last step that we are having for this procedure, that is E, is if the line has not been rejected after all four values of P and Q have been tested, is after testing the all four values of P and Q. Okay, I think we have seen these four values of P and Q in the first slide. Okay, what is, if the P is equal to delta X, what is the Q value? If P is minus delta X, what is the Q value? If the P is delta Y, what is the Q value? If the P is minus delta X, delta Y, then what is the Q value? So we are just considering if the line has not been rejected after all four values of the P and Q. Okay, the endpoints of the clipped line are determined. So we have to find out the endpoints of the clipped line directly are determined with the values of u1 and u2. So we have to consider the values of u1 and u2 to find out that intersection point directly with the help of the parametric equation. Okay, so as I told, okay, whatever the algorithm that we are having, Liang and Barsky line clipping algorithm, almost the procedure of line clipping algorithm should be followed. Okay, only the change is the calculation or how I can use the minimum operation, minimum arithmetic, minimum division, okay, to minimum operation to find out the intersection point. Okay, so that it will be more easy for us, or it will be more easy for us to have a faster line clipping algorithm. Okay, so that's why the last point of the discussion, okay, so whatever we have learned, it is more related to how exactly the mathematical equation which are used by the Liang and Barsky line clipping algorithm. So now we are just considering which are the advantages. Okay, so the advantages of the Liang and Barsky line clipping algorithm. Okay, so let us understand what is the first advantage. What is the first advantage is the Liang Barsky algorithm is more efficient. Okay, underline this word. This algorithm is more efficient than the Cohen-Sutherland line clipping algorithm. Okay, why it is more efficient? Since the intersection point calculations are reduced. We have seen in the Cohen-Sutherland line clipping algorithm, it will take more time for calculating the intersection point. Okay, but here I can say that the in Liang Barsky algorithm is more efficient because the intersection point calculations are reduced. Okay, with the help of parametric equation. Okay, so this is the one of the main advantage of the Liang and Barsky line clipping algorithm. What is the second advantage? Each update to the value u1 and u2 requires only one division. Okay, so what I will require is only one division is required whenever I update the value of u1 and u2, and based on the value of u1 and u2, okay, we are going to find out the, we come more closer to the intersection point. Okay, as we just goes on updating u1 and u2, we try to cover close, come more closer to the intersection point, and it will require only one division is required. Okay, so that is, it is more faster. Okay, now we can say, actually this is, I can say this is the second advantage, and now we just list the third advantage of this. Okay, Liang Barsky line clipping algorithm is the window intersections of the line are computed only once. Okay, of the line intersection point of the line will be computed only once when the final value of u1 and u2 have been computed. So when I will get the final value of the u1 and u2, then and then only we are going to calculate the window intersection of the line, and it is calculated only once. Okay, and this is I consider, that's why I say the Liang Barsky algorithm considered to be more efficient, which is more faster, okay, with the help of the parametric equation. Okay, so see, we may have the further algorithms also for the line clipping. Okay, so this may not be, so there may be more scientists come forward and they will find out the more appropriate solution, but all this solution lies that how I can minimize, how I can reduce the intersection point calculation. Okay, so what is the minimum way I can find out the I can minimize the time which is consumed in finding out the intersection point of the line, okay, with the window edge. Okay, and definitely if the line is partial, okay, without finding the intersection point, it is not possible for us to clip the line. Okay, for example, okay, just where I'm just considering this is my clipping window. Okay, and I'm considering, suppose this is my line. Okay, so this is my line, this is my window. So I, when I came to know that, okay, when after knowing the initial step, I come to know that this line is partial. Okay, and if the line is partial, means some, what is, I think in Liang Barsky line clipping algorithm, they have defined the partial line indicate that some part of the line is inside the window. Okay, when the some part of the line is inside the window and some is outside, means it is considered as the line is partial, and it is very important for us to find out this intersection point. Okay, so there are the two intersection point, one with the edge, top edge, one is with the right edge of the window. So unless and until we find out this intersection point, okay, I cannot remove this part. Okay, suppose I want to, I came to know that when I found this intersection point, yes, I know that this part is not inside, I can just discard this part. When I find intersection point over here, I know that can discard this part which is outside the window, and the part only the line. Okay, so I just consider here the line only from this intersection point to this intersection point is visible, and that will be shown, and remaining will be discarded. Okay, so all the different algorithms are there. I think we have learned only two algorithms. One is Cohen-Sutherland line clipping algorithm, and second is Liang Barsky line clipping algorithm. But there may be two, three more algorithms are available for the line clipping, but all, okay, will, that is what I told, the all will be focused on how we have the intersection point calculation can be reduced. Okay, all focus is that how the intersection point can be calculated with the minimum computation time. Okay, if I can find out this intersection point with minimum computation time, minimum instruction, minimum mathematical calculation, definitely the algorithm will be more efficient and more fast. Okay, as compared to all other algorithms. Okay, so these are what the advantages or whatever we have considered that is achieved maximum with the help of this Liang Barsky line clipping algorithm. Okay, so I hope all of you have understood the which are the equation, which are the parametric equations are used by the Liang Barsky line clipping algorithm to make the line clipping more faster and to have the minimum time frame or in minimum calculation how to find out the intersection point, and so that we will get the output that the part of the line which is inside will be preserved and the part of the line outside will be discarded or removed. Okay, so I considered, okay, all of you have, okay, understood, okay, the more faster algorithm as compared to the Cohen-Sutherland algorithm, with the name of the scientists Liang and Barsky line clipping algorithm. Okay, so we end our session over here. Thank you all the students. Thank you.